All right, for this one we've got 315. We are going to use the supernode concept to find the current Ix in the circuit. All right, so it gave us a hint to use a supernode. That's a good hint. I like it. But let's just look at why and where. So first things that we're going to do is supernodes, where do we use them? We use them to try to knock out as many pieces at once at a single spot. So let's just try to follow through our normal thing and see where the supernode comes up, all right? So step number one, ref node. We got to identify it. Let's make this one our ref node. So everything down here is 0 now. Cool. 2, voltage nodes. So let's identify all of our nodes here. We're going to get V1, V2, V3. All right. So let's see what else. So this is where I see the interesting easy one. It's not so subtle, but we know that this is almost the same as V1 is the same as V2 except for 6. That's the only difference. Whatever V1 is, V1 plus 6 equals V2. So we can use this actually as a really nice node. And I'm just going to circle it around. See, there's our supernode. Do you see how that is? Because we know V1 plus 6 equals V2. In matter of fact, let's write that down right now. V1 plus 6 equals V2. We got one of our equations out already. That's the inside of the supernode equation. V1 plus 6 equals V2. So now that we have that out, we can use this entire supernode. And that's going to make things a little nicer for us. So we're going to go label I0. Well, let's go down here. Label currents. Jumping ahead of myself. Label currents. Cool. And so for this, we got I0 there. We've got I1 coming down here. Ix are going to equals I2 just so I can see it. We've got one coming up here, which is going to be I3. And coming out of this one, we're going to have I4. Coming down, we're going to have I5. Coming up, we're going to have I6. Okay, I0, I1, I2, which is equal to Ix, I3 coming out, I4 coming out, I5 coming down, I6 coming up. Cool, I like that. So let's do 4. Find easy ones. Find easies. Let's look real fast. Do we have any easies? Yes, we do. I6 is going to equal 2 amps, is going to equal negative I0. So I6 equals 2 equals negative I0. We're just going to keep that stored up for later. That's not one of our final equations. This is just something to help us get through the problem. So I6 is identified, this is identified, this is identified. Cool. Let's see, any other easy ones? Don't see any. I5 equals 4 amps equals negative I5. So negative I5 equals 4. There's another one we can box up in case we see it come up with a problem. Okay. I don't see any others. Okay, so that's kind of cool. We've saved them up. Let's see what we've got now. So now we are going to solve the 5 KCL at nodes. The first one we're going to do is the supernode. We already have what goes on inside of it. This is inside supernode. That's what this is. So now that we have what's going on inside, we can use the outside of this to kind of calculate things out, which means at supernode is going to be where we are. And we're going to be able to do I0 plus I1 plus I2 plus I3 equals 0. And that's I0, I1, I2, I3, all coming out of the supernode. Coming out of supernode. Okay? So, now what are we going to do with this? We are going to solve each piece of this. So, I0 we already wrote down up here. I0 equals, negative I0 equals 2, so we can bring that negative on the other side. So minus 2 plus I1 we've got V1 to 0, so V1 minus 0 over 0.5, so V1 over 0.5, plus we've got I2 here, which is equal to IX. This is V2 minus 0 over 0.5, so V2 over 0.5. Put that in parentheses, make it nice and neat. And then we've got I3. Where is I3? I3, V2 minus V3 over 0.5. V2 minus V3 over 0.5 equals 0. Okay? So we're going to, just for kicks, multiply by 0.5 to make that nice and neat for us. So when we multiply that by 0.5, we're going to get what? Minus 1 plus V1 plus V2 plus V2 minus V3 equals 0. So let's simplify that one out a little bit. V1 plus 2V2 minus V3 equals 1. Okay. So this is one of our equations we can save up. Starred. So 2 equations, 3 unknowns. We need to find another equation. That's good because we have that node already open. So we're going to do this at V3. This is the last piece of this one. So at V3, we've got I4, I5, I6. So I4 plus I5 plus I6 equals 0. All right. I4 is going to be equal to, so I4 is going this way, so V3 minus V2 over 0.5. V3 minus V2 over 0.5 plus I5 is going to go through this. So we already have I5 over here. I5 equals, negative I5 equals 4, so I5 equals 4 plus negative 4, right? Because we're going backwards through that current. That makes sense too. Plus, our next one is I6. What is I6? 2. We already had that. We solved that somewhere. I6 equals 2 plus 2 equals 0. So if we multiply this by 0.5, let's add these up. So this is going to be 2. So it's going to equal 2 times 0.5 equals 1. And this is going to be 0.5. V3 minus V2 equals 1. There's our last equation coming up. All right, there, we got it on there. 1, 2, 3 equations, 1, 2, 3 unknowns. Let's solve this matrix, baby. V1, V2, V3, number. Let's grab our equations. We got our 1, 2, minus 1, 1, 2, minus 1, 1. And again, it doesn't matter if I grab this one first or this one, because again, this solution, as long as it's in the same line, doesn't matter which equation I solve for first. I could have solved for this one first up here, and the numbers would have come out the exact same. But anyway, so let's go for the next one. We've got, where's our next one? We've got this one. We've got 1, minus 1, minus 6, I think. Let's check that out. Minus 1. If I pull that over to the other side, yeah. 1. If I pull that over, 0 and 6. Cool. That looks right. Yeah, I did that a little weird. Sorry, guys. But that's right. And this one is 0, minus 1, 1, 1. 0, minus 1, 1, and 1. And that's going to equal, remember, A minus 1, B equals answer. And so that's going to equal our thing of minus 2, 4, 5. And that is the minus 2 equals V1. This equals V2. This equals V3. So let's go back to the top. What's it asking for again? Looking for the current IX. So IX in our thing equals I2. So IX, I'm going to write down here, IX equals I2 equals, and we can just kind of actually, as a kind of cheat, just look over here what we did for I2. I2 equals this piece. V2 over 0.5, and we just found V2 equals 4, so 4 over 0.5 equals 8 amps. Done. Whew. that was a fun one. That was not the most straightforward too. So the big one with this one is the supernode, to be able to simplify this out a little bit. You get that first inside the supernode equation, and then you can use the outside of the supernode, all of these coming out. You always have to remember with the supernodes, though, if there's something happening in here, you have to have the inside equation. If this is just a line here, you don't need any equation here. You just make one giant thing, because anything over on this side is going to equal over this side. However, this V1 does not equal V2. The stuff over here does not. There's a 6 added to it. That's why we use this equation here. But that part's the same, new. And then once we have over here, this V3 is kind of how we traditionally have done them. This is just a normal node analysis there. 3 by 3 matrix, same thing. A minus 1 of the B equals the answer. And when we're solving for the IX, which is 2, we can just actually grab the equation that we used over here. We don't even have to think about it again. Although if you want to think about it, it's V2 minus 0 over 0.5, which is what we did over here. Your call. Hope that helps.